Myself, V. SUDHARANI, working as an assistant professor in Reddy Engineering College. Today we are going to discuss topic name is TCP and UDP. Presentation outlines. Today we are discussing what is TCP, features of TCP, what is UDP, features of UDP, TCP and UDP differences. Next, TCP three-way handshake, TCP header format, buffer sizes and limitations. Today we are discuss 6 topics. Next, what is TCP? TCP full form Transmission Control Protocol. TCP sends data safely between two computers. It first make a connection so both sides agree to communicate. Next, TCP checks whether the data reached correctly. If data is loss or damaged, it sends the data again. TCP keep the data in the correct order in the used in web browsing, email and file transfer. Next, diagram for TCP. Client and server. First, the client sends a synchronization flag to say you want to connect. Then the server replies the synchronization acknowledgement. Finally, the client sends acknowledgement to confirm and the connection is successfully established. Next, features of TCP. TCP is connection-oriented communication. TCP is reliable delivery of data. TCP is retransmission of lost packets. TCP is flow control advice overloaded. TCP is error checking using checksum. Next, what is UDP? UDP is User Datagram Protocol. UDP is a way to send data between computers quickly but without guarantees. UDP does not make a connection before sending data. It sends the data immediately without checking if it arrives correctly or the right order. If order is lost, UDP does not resend it. Next, what is UDP? The diagram shows UDP sending requests and response directly without establishing a connection between sender and receiver. Each message is sent independently with no guarantee of delivery. Next, where we use UDP? UDP used video streaming, online gaming, voice calls, live broadcasters. Next, features of UDP. UDP is very fast data transfer. UDP is no transmission of lost data. UDP is no guarantee of packet order. UDP is simple and lightweight header. Lightweight header means 8 bytes. Next, differences between TCP and UDP. TCP means Transmission Control Protocol. UDP means User Datagram Protocol. TCP is Connection-Oriented Protocol. UDP is Connection-Less Protocol. TCP is reliable. UDP is unreliable. TCP is slower to connection setup and acknowledgements. UDP is faster because there is no connection setup. TCP performs error checking and retransmission. UDP is perform minimum error checking, no retransmission. Data is delivered in proper order. UDP is data deliver order is not granted. TCP header size is large, 20 to 16 bytes. UDP header size is small, 88 bytes. Used for applications like HTTP, FTP, email. UDP used for video calls, gaming, DNS, streaming. TCP used for applications like HTTP, FTP means HTTP means Hypertext Transmission Protocol. FTP means File Transmission Protocol. Next, what is three-way handshake? TCP creates a reliable connection between two computers using a process called the three-way handshake. First, the client sends the synchronization message the server to say, I want to start a connection. Next, the server responds with a synchronization plus acknowledgement message, which means I received your request and I am ready to connect. Finally, the client sends an acknowledgement message back to the server to confirm the connection. After these 3 steps are completed, both the client and server are connected and safe and reliable data transfer can again. Next, TCP connection established three-way handshake, client side, server side. TCP protocol, client side is sent to server. TCP protocol, sender side synchronization plus acknowledgement received in the client. Next, data exchange in the client to server. Next, three-way handshake. TCP establishes a reliable connection in 3 steps. First one, synchronization. Second one, synchronization plus acknowledgement. Third one, acknowledgement. Next, what is TCP header? The TCP header contains implement control information needed for reliable data transmission. It includes files like source port, destination port, secure sequence number, acknowledgement number, flags, window size, checksum, and urgent pointer. These fields help TCP manage connections, ensure correct order, control flow, and detect error during the data transfer. TCP header diagram. Header source port address, destination port address, sequence number, acknowledgement number, window size, urgent pointer. TCP header. TCP segment has 2 parts. Header occupancy is 20 to 60 bytes and data actual message. Source port's occupancy is 16 bits, port number of the sending application. Destination port occupancy of 16 bits, port number of the receiving application. Sequence number 32 bits, shows the order of data beginning sends. Acknowledgement number occupancy 32 bits, confirm the next expected data from the sender. TCP header. Header length 4 bits, tells the size of the TCP header. Reserved occupancy 6 bits, kept for the future users. Control uses URG, acknowledgement, PSH, RST, synchronization, FIN, control connection setup, data transfer and transmission. Window size occupancy 16 bits, amount of data the receiver can access, flow control. Next, checksum occupancy 16 bits, checks for errors in the header and data. Urgent pointer 16 bits, points to urgent data if URG flag is set. Option and padding up to 40 bytes. Extra features like the maximum segment size. What is buffer size? Buffers are temporary storage area used during data transmission. One on the sender side and one on the receiver side. Functions: hold data before it's sent or after it's received. Help maintain smooth data flow. Prevent data loss when transmission rates differ. Next, what is buffer size? A diagram. What is buffer size? The sender writes data into the TCP buffer and TCP sends the bytes in order of the network. The data moves as a continuous stream of bytes from sender to receiver. The receiver stores incoming bytes in its TCP buffer and the receiving process reads them in the order. Sending process, receiving process. Stream bytes. Thank you.